In lesson 5-5, we're going to multiply fractions and mixed numbers. So we're going to be actually switching gears a little bit here. So far we've been adding and subtracting fractions and mixed numbers. So now that we're multiplying, you're going to be following a different set of rules. So with your notes, it's going to be important that you keep them separate. Addition and subtraction follows their own set of rules that we've been working on. And multiplying and dividing, you're gonna ask yourself different questions or do different things. So from now on, it's really important that you understand what's happening in the fraction. Always ask yourself, am I adding or subtracting, or am I multiplying or dividing? You have to know what the problem's having you do before you get started. So step one, you must rename all mixed numbers as improper fractions. So with addition, we were able to use mixed numbers and work with them. Now that we're doing multiplication, I don't want any mixed numbers when we start. We have to get them all as improper fractions. The second step then is we're going to simplify the numerators with the denominators before you multiply. So there we can kind of say something that rhymes a little bit to help us remember this. Simplify before you multiply. So we can actually simplify the problem before we multiply, whereas in addition, we would add and then we'd simplify at the end. You're always going to want to check to be able to simplify at the very end again, but if you simplify before you multiply, you're probably going to end up with pretty small numbers that are nicer to work with than just multiplying the numerators and denominators as they are. Step three, we're going to multiply numerators and denominators straight across. So with addition and subtraction, the denominator never changed. Now that we're multiplying, we're actually going to multiply the numerators times numerators and denominators times denominators. So everything is going to change just a little bit unless you're multiplying by a factor of 1. So let's get started. Find 1/8 times 1/9. Well, first things first, we copy the problem, 1/8 times 1/9. Okay, we go back here, rename all mixed numbers. Well, I don't have any mixed numbers. Simplify numerators and denominators. Well, I can't simplify ones in any way. So then it says multiply numerators and denominators straight across. So I'm just going to kind of show an arrow here. I'm going to multiply 1 times 1, and that's 1. And then I'm going to do 8 times 9, and that's 72. So when you think about addition and subtraction, we always had to have a common denominator. Multiplication, we're not worried about a common denominator because we're actually going to multiply those two denominators together. This picture down here illustrates what's happening. We have a row of 8, or a column of 8, and then a row of 9, and then so we do 1/8, just that 1, times 1/9, again, just that 1. Now I have a total of an 8 by 9 rectangle, which is 72 boxes. And when I only take 1/8 times 1/9, that just gives me 1 out of 72 boxes shaded in. So that's kind of what's happening up here. When we multiply, we get that 1 over 72. For example, number 2, find 6 times 1/3, right in simplest form. Well, very first step, rename all mixed numbers as improper fractions. Well, six is technically a mixed number because it has a whole. So if we write it as a improper fraction, first I'm going to start by writing the problem. 6 times 1/3. Now let's rewrite 6 as 6 over 1 times 1 over 3. Okay, now we'll go back to our directions. Simplify numerators with denominators before you multiply. Okay, so can we simplify the 6 and the 1? Well, we can make 6, but we just changed it, so we don't want to do that. Can we simplify the 1 and the 3? No. But now we can look diagonally, and we can actually simplify the 3 and the 6. So I'm going to divide by 3 to make that a 1, divide by 3 to make that a 2. Now, I can't do anything with my 1s here, so we just leave that. So we can simplify cross diagonally and up and down. But you cannot simplify numerators with numerators or denominators with denominators. It has to be a denominator with a numerator. So now we can multiply straight across. That's step 3. So 2 times 1 is 2, and 1 times 1 is 1. And now, again, write it in the simplest form. And the last step, step 4, says to simplify, so we can rewrite that as just 2. And that's our answer. For example 3, again, let's start by writing the problem. 3/12 times 4/5. Okay, I don't have any mixed numbers, so I can skip over step 1. Now, simplify numerators and denominators. Well, 3/12. I can simplify 3/12. I can divide both of these by 3. So I'm going to change the 3 to a 1 and the 12 to a 4 because I'm dividing by 3. So 3/12 is the same as 1/4. And now 4/5, I can't do anything there, but I can do a denominator and a numerator right here. So I can change the 4 to a 1 and this 4 to a 1. And now let's go ahead and multiply straight across. We get 1 times 1 is 1, and 1 times 5 is 5. And that is in simplest form, so we're done right there. Example number 4, again, start by writing your problem. 4/9 times 6/7. I don't have any mixed numbers, so I don't need to start there. I can't simplify the 4 and the 9 because that's an even number and an odd number. I can't simplify the 6 and the 7, but when I look across here, that's a 6 and a 9. So they're both divisible by 3. So we can go ahead and do that. I'm going to divide by 3 to get 2. I'm going to divide by 3 to get 3. Okay, and so we can simplify those, and that makes us a little smaller numbers. 9 times 7 would have been 63. That's a pretty big number. So now we can just do 3 times 7, which just gives us 21, which is much smaller to work with. And then 4 times 2, which is 8. And so 8 over 21 is in simplest form. So because we simplified over here, we don't have to simplify as often over here. But you always want to check to see if you can. It was a lot easier to check these numbers and multiply these numbers than if I would have done it without simplifying. 4 times 6 is 24, and 9 times 7 is 63. But I know that 24 and 63 are both divisible by 3. And so if I put those in the L method, 24 and 63, and again, I'm just proving that you can multiply these and simplify later, but it's a lot harder to do because the numbers are bigger. So I can divide by 3, and this is going to be an 8. And this is going to be a 21. And so look, at the end, I still get 8 over 21 as an answer, but I have to deal with these larger numbers that I might not be able to work with in my head. So I'd rather do it before I multiply when the numbers are smaller. All right, with example 5, I'm going to write the problem 1/3 times 6 and 6/7. Now I do have a mixed number. I have to take care of this first. Now, when you think of 6 whole with a denominator of 7, well, what I need to do is I need to do 6 times 7. So that is 42 parts. 6 times 7, okay? And then, so 6 times 7 is 42. So I need to add 42 to the numerator. 6 times 7 is 42. So I need to add 42 to the numerator. The denominator won't change. Again, remember, we're just renaming that fraction. So I'm going to rewrite that as 1/3 times 48/7. Now, how did I get that? 6 times 7 is 42. So I added that to 6, which is the numerator before it. The denominator does not change. Now, I'll check to see if I can simplify before I multiply. Well, I'm not quite sure about 48. So 4 plus 8 is 12, and 12 is divisible by 3. So I know that this will work. So I'm going to do 3 divided by 3, which is 1, and I really like getting 1 in the denominator anyways. So 48 divided by 3, well, if I need to, I can just draw a quick division bar, and 3 goes into 4 once, and that's going to leave me with 1 left over, so I'm going to have 18. 3 goes into 18 6 times. So this number is going to be 16, and I can just kind of leave that right there if I want. Now, I can't simplify the 16 and the 7, so I'm going to multiply straight across, and I'm going to put my arrow at the number I'm multiplying. So it's going to be 16, and 1 times 7 is 7. Now, I can rename that. How many whole can I make? Well, every time I subtract 7, I make a new whole. So if I subtract 7, I'm going to get 9. And I can subtract 7 again, and I'm going to get 2. And every time I subtract 7, that's a new whole. So those are 1, 2 wholes. So I'm going to get 2, and then there's 2 left over. So 2 and 2 sevenths. And I cannot simplify 2 sevenths. So I'm done. All right, for our last example, again, we'll start by copying the problem. So 2 fifths times 4 and 3 fourths. Again, always check your symbol. We are multiplying, so that means we need to follow the multiplication rules. So first and foremost, we got to take care of the mixed numbers. So again, multiply the whole number times the denominator, so we find out how many parts we have. 4 times 4 is 16. Then add 16 to your numerator. So 4 times 4 is 16, and we need to do 3 plus 16. So rewrite the whole problem. 2 fifths times 19 fourths. Again, we got 19 because 4 times 4 is 16, so we actually have 19 fourths, which is the same as 4 and 3 fourths. Now we'll check to see if we can simplify anything. And I see that we can. The 2 and the 4 can simplify. So the 2 is going to become a 1, and the 4 is going to become a 2, because we're dividing by 2. And I always want to see you writing what you're changing them to. Cross off the numbers. I can't do anything with the 5 and the 19. They're both prime numbers, and they won't go into each other. So this is as far as I can get. So 1 times 19 and 5 times 2. So I'm going to get 19 over 10. I can take 10 away from 19. So again, remember, every time I take a 10 away, I'm making a whole. So minus 10 equals 9. I can't take another 10 away, so I'm going to have 9 left over. So the whole thing equals 1 whole and 9 tenths. And I can't simplify 9 tenths at all, so that is my final answer. All right, if you'd like to look at any more examples, please check out the tutorials, which I've loaded onto Moodle. You can always check the step-by-step homework helper. And today we're actually going to have a worksheet, so be sure to check the answer key that I've loaded onto Moodle for you to check all your answers with, along with all of your correct work.